Good morning. Today we're going to finish off 7.4, which is solving polynomial equations in factored form. But first off, I want to go ahead and refresh your memory about where we left off with the last thing from 2 days ago. So I'll switch over to another notebook here. And it was this section right here about using the greatest common factor in order to find polynomials. So the instructions for this type of problem said you had to factor out the greatest common factor of two things. In order to do that, you have to, number one, find the greatest common factor, and the second part is actually to divide it out. So as you can see from the example that I did have you write down in your notes, you write down what's called the prime factorization of one of the numbers, in this case 4x to the fourth, and that would be factored into 2 times 2. And then 4 x's, and that became 4x to the fourth. And then you have 24x to the third. Now in this one off to the side, I did do a factor tree. So 24 could be factored into 6 and 4. Neither of those two numbers are prime numbers. So I went ahead and factored the 6 and the 4, and I got 4 prime numbers right there. So that would be the prime factorization of the 24, the 2 times 2 times 2. Times 3, and then because I have 3 x's right there, I need 3 x's right here. And then finally, to figure out the greatest common factor, we have 2 times 2 because they each have a pair of 2's. So here we have one pair here and a second pair, and there are no other pairs of numbers. Next up though, there are 4 x's on top and 3 on the bottom, so I can match up 3. And you notice I had to connect those two that way. So that's where the 3 came from, giving me 4x to the third. So that's the GCF, and what you do is you divide it out. And that's what factoring out means, to divide it out. So here is the GCF right there. It doesn't actually go away completely, it just comes out front of the expression. So here's the problem right there, and we divided each one by 4x to the third. So to get the x there, the 4 divided by 4 is a 1, and then x to the fourth divided by x to the third is just x to the first, so I just wrote x. And over here, x to the third divided by x to the third canceled out, so we're left with 24 divided by 4, which is 6. Here's another example of that for you to watch, and you can see from the upper right corner, it says it's 12x to the third plus 3x to the second.
Factor out the greatest common monomial factor from 12x cubed plus 3x squared. The greatest common factor of 12 and 3 is 3. The greatest common factor of x cubed and x squared is x squared. So the greatest common monomial factor of the terms is 3x squared. So 12x cubed plus 3x squared equals 3x squared times the quantity 4x plus 4.
Okay, so over in the chapter packet, let's see if you know how to do this. So I'm going to do a couple with you here and then have you finish the rest. So taking a look at number 13 here, I see 6x squared plus 3x. And I have to think, what is the biggest number that will go into both of those terms? And it would be a 3. So I know I have to divide them both by 3. And then also, they each have at least one x, so I can divide them both by 3x. That 3x is my greatest common factor, so I am factoring out that number. That's going to go out front, so I have 3x, and then I put my parentheses there, and whatever is left goes inside the parentheses. So over here I have 6 divided by 3, which is 2. And I have x squared divided by x, which is x. Over here, 3x divided by 3x, that's just a 1. Okay, I'll do one more and then have you work on the rest. So I'm looking at first the numbers, the 4 and the 20, and it's always a good thing to look at the smaller number because the bigger number can never go into the smaller number. So 4 does go into 20, so it's going to be 4. And then they each have y's here. This one has 3, so that's the number I'm going to use, x to the third. Okay? So 4y to the third, that is my GCF. That's going to go out front. So I have divided it out, which is what they call factoring it out. All right, 4 divided by 4 is just 1, so we don't really need to write it. Y to the fourth divided by y to the third is y. And then I have a minus there. 20 divided by 4 is 5. And y to the third divided by y to the third, it's just 1, so it cancels out. So that's my answer right there. I'd like you to go ahead and complete 15 through 18. Okay, here are the answers that I came up with on 15 through 18. Hopefully you did a good job with that one. Note that on number 16, it is a little weird there. You can only divide by the z because 2 does not go into 7. So go ahead and make any changes that you need to make and continue the video when you're done. Okay, next we're going to move on to the very next section, and you're going to see how it's all connected. And I already wrote here the first two examples that we're going to do. So it's called solving equations by factoring. So that does involve finding the GCF like we were just doing. But notice now we have an equation there, and we didn't have that on the previous example. So we have equals 0. We don't have equals 0 yet here, but we will because I'm going to move everything to the left side. So first off, on letter A, I'm looking at those two expressions there, and I have to divide out the GCF. And remember, dividing out is the same thing as factoring. So I noticed we have a 2 and an 8, and so the number 2 is going to go into both of those. So I know I can divide by 2. And then also, they each have at least one x. So I can divide by 2x. Now that's not really just going away. It's just coming out front. So I'm taking it out of the full expression, putting it out front, and then I'm going to have stuff left behind. So 2 divided by 2 is a 1, so it can go away. X squared divided by x, that's just going to be an x. And then plus, I'll have 8 divided by 2, which is 4, and the x divided by x goes away. So here's where I am right now. Now 2 days ago, we did lots of problems that started right there, so we just have to continue on. This is from the zero product property. If two things are multiplied together, this is a term and this is a term. Together they're multiplied. This is the product. It's 0. So that means at least one of these two terms is 0. So I just have to say either 2x is equal to 0 or x plus 4 is equal to 0. From there I solve each of those. Well, if 2 times x is 0, x would have to be 0, and on the right side I would subtract 4 from both sides and write x is equal to negative 4. So remember, those can be referred to as your answers. They're also called the solutions. Another word for them is roots, and then also zeros. So we have synonyms that mean all the same thing. All right, looking on the other side, I need to have everything on one side of the equation, and right now that's not happening. So what I'm going to do is I'm going to subtract 15n from both sides. So that's going to give me 6n squared minus 15n, and that's equal to 0. Next, I have to figure out what is the greatest common factor of those two numbers. Now 6 does not go into 15, so I have to think of the next number that would go into 6, which is a 3, and that does go into 15. So I'm definitely going to divide by 3. And then I notice the variable is n. This one only has 1. That one has 2, though. So I can divide by 1n. I can't go by 2 since this one doesn't have 2. So that is the GCF, that 3n. So I'm going to put that out front, 3n. And then whatever's left goes inside. 6 divided by 3 is 2. N squared divided by n is n. On the right side, I have a minus there. 15 divided by 3 is 5. N divided by n is just 1. That cancels out. So that's going to be equal to 0. Okay, so I'm going to go a little bit lower on the paper than the other one because I'm kind of right at this spot right here. So I need now to say that I'm going to use the zero product property. One of these two terms has got to be 0. So it's either 3n that's equal to 0 or it's 2n minus 5 that's equal to 0. And I have to solve each of those. So on the left side, it's just a matter of writing down the answer. On the other side, though, I have to do a couple things. I'm going to add 5 first to get 2n by itself, and then I have to divide by 2. So I do get 5 over 2, and you can just go ahead and leave it as 5 over 2. So it's n equals 0 or 5 over 2. Here are a couple more examples like that I'd like you to check out.
Part A, solve 4x squared plus 12x equals 0. First write the equation, 4x squared plus 12x equals 0. Next factor the left side of the equation. Because the greatest common monomial factor of 4x squared and 12x is 4x, factoring the left side of the equation gives 4x times the quantity x plus 3 equals 0. Next, use the zero product property. The zero product property says that if the product of two real numbers is 0, then at least one of the numbers is 0. So 4x equals 0, 4x plus 3 equals 0. Solving the equation 4x equals 0 for x gives x equals 0. Solving the equation x plus 3 equals 0 for x gives x equals negative 3. So the roots are x equals 0 and x equals negative 3. Part B. Solve negative 10a squared equals 8a. First write the equation. Negative 10a squared equals 8a. Next subtract 8a from each side of the equation to get negative 10a squared minus 8a equals 0. Next factor the left side of the equation. Because the greatest common monomial factor of negative 10a squared and negative 8a is negative 2a, factoring the left side of the equation gives negative 2a times the quantity 5a plus 4 equals 0. Next, use the zero product property. Using the zero product property gives negative 2a equals 0 or 5a plus 4 equals 0. Solving the equation negative 2a equals 0 for a gives a equals 0. Solving the equation 5a plus 4 equals 0 for a gives a equals negative 4/5. So the roots are a equals 0 and a equals negative 4/5.
All right. Next, I'd like you to go back to page 223 in the packet, and we're going to focus on the next group of problems there, so 19 through 24. I'm going to do number 19 with you, and then I'm going to ask you to do the remaining ones. So I'll go ahead and move this up just a little bit here, and yeah, that should be good. So it says here we have 6k to the second plus k is equal to 0. So this one doesn't have a number other than a 1 in front, so the only thing that I can divide would be a k. That is the GCF. So I'll just put that right there. So underneath, I'm going to have k and then times, and then I have to do my division, which is the factoring part. 6k to the second divided by k is 6k. And then k divided by k is just a 1. So that equals 0. Now I'm going to do the zero product property. So that means either this term is 0 or this term is 0. So I get one of them right away. K equals 0. I'm done with that part. But then on the other side, I have to say 6k plus 1 equals 0. Then I have to get the 1 out of there, so I'm going to subtract 1 from both sides to get 6k equals negative 1, and then divide by the 6 to get k is equal to negative 1 over 6. So here are my two answers, and I'll put in the k equals again here. So it's k equals 0 or k equals negative 1 over 6. Please go ahead and work on problems 20 through 24 now, please. Okay, I have gone ahead and completed the rest of the problems, so please check your work and make any corrections that you need to make. Because I want to make sure that you do have all these problems filled out in your packet for you to review for later, and then also, of course, have everything in your notes that we were working on. I'm going to wrap this video up, and then I'm going to have one other part that you'll have to look at separately to finish out today.